Hello, everybody. We are back in our last session for today. Where is it? We ended with identifying functions and documentation. We identify by their names and their RET. The RET is the number of arguments they accept. You access the documentation by typing this letter. Some functions arrive with the kernel when you load the Elixir, like trunk. Some others will have to be uh, accessed with their name, with their module. Let's use an arity of 2099. Oh, there is no documentation for such a function. So let's use one arity, and we found it. Then you have downcase and capitalize that we already mentioned. So name and arity because it's important. You just see here. Sometimes, as we saw earlier, you omit the arity and you give. It's kind of helpful. This system allows you to, uh, you know, you just need to try things. Defining function, anonymous functions. What is it? Allows to store and pass executable code around as it if it was an integer or a string. Some people call it a first class function. This is just from the training courses that I have been taking since more than 10 years. Uh, okay, anonymous functions in Elixir, something like that. Defining anonymous functions. Anonymous functions in Elixir are delimited by the keywords fn and ent. And we put the at okay. This is the anonymous function. Okay, there is a delimitation in here. Here is the syntax fn and they're using the match operator to match this variable at. So at will be storing this function, a function without name, but it will be stored using this variable. So fn, the argument list, a, b, the arrow, to separate the argument list and the body of the function. So see this fn and n enclose the anonymous function. Okay, you can draw some lines over here, and then you have this arrow that separates the argument list and the body of the function. In here you accept two arguments and return its sum. I'm going to write this. Okay, those we don't have any equals a plus the end, and it says it's a function and some number. You know, uh, they don't have names, but they decided to put this and the RET two arguments, and the slash the RET, and where is um, this is an atom. I'm not deciphering this, right? But this is how it's stored. The important part is the syntax for anonymous function. Now you started to say, can I do it without this comma? And it says no. So we are back to this. And we get our function Look at this. This didn't change. Okay, great. An example above, we define a function, blah, blah, blah. You can represent a certain value by function. Is opaque. Okay, here's the thing. The function was defined in the shell during the evaluation. This is good to notice. We can invoke anonymous functions by passing arguments to it using a dot between the variable and the opening parentheses. This you see how to define anonymous functions. Now, how do you call that function with the dot, and you get the number? And then you start with your experiments. Say, can I omit the dot? No. Can I do silly things like this? No. So syntax is important. It's the name of the function, the name of the variable that you have this function stored, and then the arguments. Let me grab this part and clear the screen, and then someone will say, can I call this function if I put some parentheses? Remember to follow the code standards, code guidelines that people have defined. So even if we found some syntax available, we shall go with the flow. And you see, it can be done like this. I don't think without parentheses. Someone will say, are you so silly to try this? I don't know. Okay, so you can use it without first storing the variable, without first storing the function, the anonymous function, in a variable. That makes it clear when you're calling an anonymous function stored in the variable add opposed to a function named add2. This is important. You are calling an anonymous function stored in here. This, when you see this guy, there is some anonymous function stored over here. Instead of calling a function with name, whose name is at. For example, if you have an anonymous function stored in the variable is atom, there is no ambiguity between is atom and is atom. This is the one that we saw yesterday. It's both used the same as atoms syntax. The only way to know the actual behavior of this atom will be by scanning all code for a possible definition. Host maintainability. So, okay, this is here a lot of text, and you now focus on this. Sorry. Anonymous functions are also identified by the number of arguments they receive. We can check if a value is function using isFunction, which only takes one parameter, and also check its arity by using isFunction, which takes two parameters, the name of the function and the arity. I'm not sure, because if you're checking for the arity, okay. Check if add is a function that expects exactly two arguments. True. Is function, and you pass the variable that has the function stored, the anonymous function stored. True. Does this function Does the function stored in this variable accepts two arguments? True. It accepts one argument, false. And the important thing here is to remember that this function will tell you if you are dealing with some functions. And remember this is important. This is the core of the whole section. Closures. Anonymous functions can also access variables that are in scope when the function is defined. This typically referred this is typically referred to as closures as they close over their scope. Let's define a new anonymous function that uses the add anonymous function we have previously defined. Here's the thing. Anonymous functions can also access variables that are in scope when the function is defined. That's all. We have add somewhere upward, somewhere above in our session, and now we have double storing this anonymous function accepting one argument. Look at this. Now the arrow, the body of the function, and it's using add by means of the dot with two parameters that is mentioned over here. And you use it double 2, this is the A, 2, and you perform the summation. 2 plus 2, 4. I don't know if we need to write this. You just need to remember that you can access the variables that are in scope inside here. When the function is defined, this is the important thing. This is important too. A variable assigned inside a function does not affect its surrounding environment. Look at this, we have the parentheses. A variable assigned inside a function does not affect its surrounding environment. So in here we match x with 0 and return 0, which is this. But x is still 42 in the surrounding environment because inside the function this does not affect the outer scope. But we can use the variables that are available when you define the function. And then clauses and words. Similar to case 2, we can pattern match on the arguments of anonymous functions, as well as define multiple clauses and words. Okay, you can pattern match on the arguments of anonymous functions. Okay, this is great. Look at this. Let's write this. Yeah, let's write this. Let's write this. F equals Fn, your delimiter, 1, 2, 3, 4, and then the two arguments, the argument lists, and it includes a word and x greater than 0. You return x plus y, x plus y, no word, x times y, and we end, remember, f and but now we have we are pattern matching on the argument list. we will make an experiment because uh, I was thinking that is it possible to have one argument in here and then two arguments in here and three arguments in here? That will make the function vague, I suppose. And in here we are seeing an error because I used the arrow. And you know this fat arrows they say in JavaScript. If I remember correctly, fat arrow instead of the thin arrow or this little fellow. So let's stay away from this. Clear the screen. 1, 2, 3, 4. When sorry, I need to write faster. Okay, now what? X time Y. Where is this thing? And then end. So did you get it? There are two patterns, two argument lists. I'm saying you probably know this, but in the case someone is just here having a good time, uh, these are two argument lists, two patterns, and this has one word. If this gets fulfilled, use some variables. If it's not, then we multiply the thing, and then we apply the function. 1, 3, x greater than 2, greater than 0, yes. And here, -3, because it was multiplied. Now, let us test our question. Function g, and say some silly, one argument equals 99. But if someone say gives me two arguments, I will say okay, and then finish. And it says that using the underscore because we are not using it in the body of the function, so it's okay. But kind of in here's the thing that we wanted to test different arithmetics in anonymous functions. It's not cool. So be cool with the Elixir system. Okay. Oh, look at this. We are ahead of the curve. The number of arguments. Most like I don't know. I don't think it's the case. I like to ask questions, naive questions. The number of arguments in each anonymous functions clause needs to be the same. Okay, we know that. The capture operator. Throughout this guide, we have been using the notation name arity, okay, to refer functions. It happens that this notation can actually be used to capture an existing function into a data type that we can pass around, similar to how anonymous functions behave. Let's see something that I remember this this letter character, and we have an expression, and we have the term the data type and the reference modules. Okay, you somehow remember this. So we said in a previous lesson that we are going when we arrive this to this uh, topic, we will test that character to see the type of the functions. So let's see and provide it with parentheses first and see what happens. And we have what happened. I don't see. Oh, here it is. We are using this character and then the function between parentheses. So we will remove the parentheses. And it says determines the function that we saw this, remember? Data type is a function, local, and type it's local. It's different from this, the output for this. Now it's saying it's local. Arity2, this is an anonymous function. Let's see if we can remove the parentheses. And it says the same thing, arity2 local function. I was expecting something like int, comma int, arrow int, something like this. I was expecting something like this, but most likely there is a way to extract this information. Like it will be presented later. Closures. Okay, capture an existing function into a data type that we can pass around to an existing function into a data type. And in here they are storing is atom with the arity /arity. So the important thing is this fellow ampersand, if I remember, capture operator in here. This function found through font hello through font. So you're just storing existing. You're using this operator to store existing functions into variables. I'm going to copy paste from here. And now font, which is a received keyword in certain languages, ampersand, and then let's see what happens. It says that it expects an existing function, but it mentions the module. Some functions are loaded in with the kernel as they say. But let's do what they are saying. Is atom. Okay. Then apply. And it says false. Okay, use this to store existing functions into fun. Once a function is captured, we can pass it as an argument. Look at this. Or invoke it Okay, and I was saying, I was thinking, where did they pass the function as an argument? Well, it's in here. The function, the existing function is stored in fun, and now you can use it as an argument or apply it as outside. In here, fun is storing the length for a string, and you use it. Since operators are functions in Elixir, you can also capture operators like the plus. Now you have your custom name for the plus operator, which is great. Mm, Okay, yes, we are about to finish. I don't think no one is connected. Please look, if you are new to all this stuff, it might look cryptic. And I say, is this for me? But it's just simple. Here is the capture operator, the operator, and the arity. And then you apply the function. The capture syntax can also be used as a shortcut for creating functions that grab existing functions. But okay. Um, this arity2. This is an anonymous function. The capture syntax can also be used as a shortcut for creating functions that grab existing functions. For example, imagine you want to create an anonymous function that checks if a given function has arity2. And then you have your anonymous function, fun, this function, provide the function, and the arity. And you ask, is arity2 at true? We are providing some function name and checking if it has 2 as an arity. How do you do that? By accepting a function and passing it as an argument to each function with the arity2. Okay? But using the capture syntax, you can write it as arity2 is function. Okay, this is cool. But using the capture syntax, you can write it as is arity2, then the capture operator. The capture operator is function, the existing function. And in here we have this again, the capture operator, but with number 1. I suppose it is here, but you can make guesses before reading. It will take, this will be replaced by the argument that the color is given to it will give to you. It's arity2 and it gives you that, and then you replace it over here. Okay? And then you have the explanation. Represents the first argument passed into the function. Therefore, its arity2 anonymous functions definables are equivalent. And you need to choose which one do you like the most. I think this is cool. Once again, these two are equivalent. Once again, given operators are function calls. Operators are function calls. The capture syntax shorthand also works with operators or even string interpolation. This is an operator, but this is a function call. The operator is in fixed. It accepts two arguments. So this is called this sentence expression. Yeah, this expression is captured in the plus operator, and it's capturing the first argument that you are going to provide, and it adds a number one. So in increments, you should be calling this increment if you feel like doing so, and you provide one, which will be replaced over here, plus one, and you get two. And then fun to probably this should be called explaining to you this thing, reading for you this thing. This has become silly. Let me write this instead for me because it is an exercise for me. Fun to ampersand. We are doing a string interpolation here. Good. One. Oh, look. What are you capturing in here? And you call it. Good one, but for us it will be. Oh my god. Nice. Good, nice. I love this. It's exactly the same as this anonymous function. These are equivalent, and you can decide you can decide which one you like the most. So in here, you are capturing this operator, the string interpolation, because these are the limiters for the string, and you are capturing the first argument. Okay, so this is kind of cool. And see you any other day with this material. I will try to give it another approach. So because you know how to read, and this is not a tutorial, uh, so I'm not sure how to approach this in which I don't want to be just reading inside. There is nothing wrong with that. I don't know. This will be cool. Look at this. This is, I suppose this is a dense topic. All of this is new. Charles, I will not have to say too much all about this. Binaries. It will be a refresh. Thank you very much. And see you. Let's finish. See you in our next section.